Now, finally, here's the summary. Before creating an optimization AI model, you should consider whether a meta model is absolutely necessary for optimization. The answer is no. If you simply create a generative model and connect it to a CA solver, optimal design is possible even without a predictive AI. However, if you want to achieve optimal design more quickly using predictive AI, you can create a meta model with deep learning and then attach a conventional optimizer, such as a GA, to perform the optimization. Alternatively, if you use inverse design with a deep learning meta model, like the tandem network for reverse engineering mentioned earlier, you can achieve real-time optimal design. And although I mentioned deep learning-based optimal design, which is currently the most actively researched area, there are still issues such as scalability that need to be addressed before it can be applied in industry. And reinforcement learning also seems to be somewhat stagnant when it comes to optimal design. That's because we design everything at once, thank you. Generally, when we do something like shape design, we don't design each design parameter one by one in sequence. When everything is designed all at once, there are cases where reinforcement learning doesn't fit well. Since it's suitable for serial actions, it's actually a great fit for things like layout optimization in chip design. Next, if you look at the research trends, the key is not optimizing in the X space, but rather optimizing in the reduced G space. And then with inverse design, you can optimize in real time. And instead of optimizing parametric 3D designs, you can extract deep learning features in a non-parametric way to achieve optimal design. Also, in such cases, you need to keep advancing so that learning is possible even with small data. This is the last part. If you look at the process of developing an optimization AI model, it starts with deciding to develop a model for optimization. Then first, you need to check whether parameterization is possible. If it's not possible, you need to use a generative model to extract features and define the design variables in the latent space. If you can parameterize the latent space, you can simply define the parameters as design variables. For problems that are well suited to parameterization, it's advantageous to parameterize them. There's really no need to solve it in a non-parametric way unless necessary. Next, you need to check whether you have analysis data. If you do, and you have a lot of it, you can use predictive AI to build a meta model. If you have a meta model, you can optimize using gradient-based methods, heuristic methods, or even deep learning-based inverse design. However, if you don't have analysis data, you can simply combine simulation CA directly and perform optimization using gradient-based methods or solve it heuristically. However, if there is no predictive AI model, inverse design cannot be performed. That brings us to the end of the lecture for today. Thank you.